In this video, we're going to try to compute this integral between 0 and plus infinity of 1 over x plus 1 times x plus 2. So this is an improper integral because we have this infinity here. Before we proceed, we must check the function in our interval. So we have x plus 2, 1 over x plus 1 times x plus 2. It's 0 when x is minus 1 or x minus 2. But they are not in this interval. So our function has no discontinuities. So the issue that we have is this plus infinity. So this is a improper integral of the first kind. We can prove if this integral exists or not by first using some comparison to what we know. But all we know is this integral dx 1 over x to the power alpha dx is between 1 and infinity is convergent 1 alpha is bigger than 2. So we're going to use this one here. We're going to split this integral into two parts from 0 to 1, 1 over x plus 1 times x plus 2 dx plus 1 plus infinity over 1 over x plus 1 times x plus 2 dx. So let me clarify some points here. This one is the definite integral that we know. This is finite. We have no issues here. And we had to split this integral into two parts because we want to use this criterion here. Okay, that's why we had to do this. So 1 over x plus 1 times x plus 2 is the same as 1 over x squared. So since this one is convergent to 1, we integrate between 1 and plus infinity. This is also convergent. Okay, now we show that this integral is the sum of this finite integral and this convergent integral. Therefore, this integral exists and it's finite. We can compute its value. Okay, so we can use the definition of the improper integral. So the integral between 0 and plus infinity of 1 over x plus 1 times x plus 2 dx is defined as the limit as x goes to infinity of this one between 0 and x. Let's change the variable here, t plus 1, t plus 2 dt. Okay, there is nothing happening here. It's just dummy variables that won't affect anything. So now we know how to compute this one. Okay, so this is a fraction that we can decompose very quickly. So 1 over t plus 1 times t plus 2. So here it's improper fraction. It's going to be 1 over t plus 1. Let's see if I put a minus what I get. Let's check. T plus 2 minus t plus 1 is 1. Yes, so this is the right one. So now I have this integral is equal the limit as x goes to infinity of 1 over t plus 1 minus the natural log, or let me do it before that, 0 between 0 and x of 1 over t plus 1 over t plus 2 dt. Now I know this is the log, so the primitive of these ones are the logs. So the limit as x goes to infinity. So now I can change. I'm going to do two things here. I'm going to use the log. So this is the natural log of t plus 1 minus the natural log of t plus 2. I'm going to use the properties of the log to write this one as the t plus 1 over t plus 2 between 1 and x. Okay, now I plug the values. Okay, I plug the values here, the limit as x goes to infinity. I'm going to get the natural log of x plus 1 over x plus 2 minus the natural log of, let me see, when I have the first one, let me see when I plug 2 over 3. Okay, so the When I plug 1, I get 2 over 3. So that's the integral that you get. So the issue that you have here is that when I do the limit, so here I get 1, okay? I get 1 without the log. Since the log is continuous, I can enter the limit inside. I'm gonna get the log of 1 here, and the log of 1 is 0, so I get 0 minus the natural log of 2 over 3. I'm gonna switch this one, so I'm gonna say 3 over 2 to make it positive. Okay? So this one here. So I need to change something because I did evaluate this one between here. Now here, this is the mistake, between 0 and x, not between 1. So if I do it between 1 and, so I'm gonna get just here 1 over 2. So 1 over 2, sorry, this is a mistake, 1 over 2, and here I'm gonna get the natural log of 2. So this is the mistake that I made here, and I'm correcting it because I did integrate between 1, so I was just working here, but here I'm working between 0 and plus infinity, so it's between 0 and x, not between 1 and x. So that's why I had this 3 over 2 first. Now we have the value of this integral is just the natural log of 2, and since it's finite, this means that this integral is convergent, and we know its value, it's the natural log of 2. Okay, this is the kind of integral that we need to be careful about. Check the function, see if you have any discontinuities. Sometimes we're going to see that we will have a combination of the improper integral of the first kind and the second kind. But for now, we're doing them separately. Next, we're going to do combination of them. Thank you very much.